If you followed this discussion so far on pre-stressing concrete, it may have occurred to you that the placement of this reinforcing can have a big effect on what it does to the concrete structure. You may have also wondered just how much force we're using to squeeze this concrete together. So let's take a look. Let's talk about the force first. Pre-stressing steel is very high-strength steel. Typically, we use what we call grade 270 pre-stressing steel, which means it has a breaking strength of 270,000 pounds per square inch. Just for a reference point, typical rebar reinforcing is grade 60. When I install this pre-stressing steel, I'm going to tension it, remember, by anchoring at one end and using a hydraulic jack to pull on the other end. Now, all of this is a somewhat complicated procedure. It could probably take up its own course, but for our purposes here, I want you to understand just how much force we're using to pull on that cable. Using that hydraulic jack, we stress each cable to a force of about 33,000 pounds, not PSI, pounds. So again, I'm going to provide you a reference. That's like hanging 6 cars off the end of that half-inch cable. You wouldn't stand under those cars. Don't stand behind that hydraulic stressing jack. If something were to slip or break, that 60-pound steel jack would be propelled backwards with about as much as 33,000 pounds of force. You can't move fast enough to get out of the way. And if it hits you, you're going to lose every time. Believe me, I've investigated 2 fatalities involving this operation. There's no room for mistakes, and everyone involved in this operation needs specialized training before they go to work. Now, while we're on the subject of safety, keep in mind that when we stress these cables, we are actually stretching them. They'll elongate just like a rubber band. In fact, a 100-foot-long steel cable will elongate about 8 inches. Now, if this breaks or gets cut, think about that rubber band. If you stretch it out, someone comes up and cuts it in the middle, which way does it go? It goes both directions. So keep in mind that when you're looking at places that might be dangerous to stand during the stressing operations, both ends of the cable are hazardous, not just the end with the hydraulic jack. Let's get back to all that force, and let's think about what it does to the concrete it's squeezing together. If I place that pre-stressing steel in the middle of a slab or a beam, and I do that in a flat profile, I get a simple squeezing force that puts the concrete into compression and increases the bending strength and helps prevent cracking, like my tennis court or house foundation examples. If I place that same steel down in the lower portion of something like a beam, I'm actually going to squeeze the bottom more than the top, and I can induce bending into the concrete. Sometimes I do this on purpose. For example, if I'm making precast concrete pieces at a plant for a parking structure, we design them to have this bending or camber so that when I erect them in the field and gravity pulls down on the middle a little bit, they deflect and flatten out. In this case, that's what I want it to do. But back in my tennis court examples, getting those cables installed in the middle is really important because I don't want to have any bending. Now, if we go back to the case of installing the pre-stressing steel in that draped profile, where I have my high points over the columns and low points in the mid-spans, so remember when I stretch those cables, I lift up on the center of the slab, it's really important that I get those high and low points correct. Again, the layout and installation of pre-stressing steel is somewhat complicated, probably take up its own separate course. But what I do want you to understand here at this point is that tolerances are extremely critical in this type of construction. High and low points are specified by the designer, and getting them right is critical to the performance of the structure. If I have too much uplift, I can actually bend that concrete to the point where it's detrimental. And likewise, if I flatten out that profile of the pre-stressing steel cable and I don't get enough uplift, the structure's not going to perform like it was designed. So let's close out this chapter on pre-stressing by summarizing a few things. Pre-stressed concrete, whether it's precast and pre-tensioned or cast in place and post-tensioned, can provide some incredible advantages. And it's another one of those things that really increases the usability of concrete as a building material. It gets us longer spans and thinner sections, but it's a specialized trade and it takes some specialized training and equipment. With the very high forces that we're tensioning this steel to, we have a lot going on inside that concrete, and that's why we call it active reinforcing. And we want it to work right, so tolerances are very tight. Make sure everyone involved is properly trained and follow those plans.